Okay, lesson 1-6, solving quadratic equations. In this lesson, we will solve quadratic equations using 3 different methods. Not one of these methods is new, just some need more practice remembering how to use them in others. Factoring is our first method, completing the square, and then using the quadratic formula. Okay, what does it mean to solve an equation, first of all? To solve an equation is where we determine the value of, that didn't work. Determine the value of x Sorry about that. Technical difficulty here. So we determine the value of x when y is equal to 0. Okay, that's to solve. What's a quadratic equation? A quadratic equation is an equation that's degree, its highest exponent is an x squared. So this is a quadratic equation. This is a quadratic equation. This is a quadratic equation. Okay, quadratic equations don't need to be trinomials, meaning that they all have 3 terms. What makes an equation quadratic is having that x squared term, and that x squared term being the highest exponent represented. Okay, we talked about this a little bit, but what is finding a solution? So we will come back to this over and over and over again. A solution is the same as determining the root of an equation, which is the x-intercept of the equation. Okay, and that makes sense because think about what we're doing. We're finding the x value when y is equal to 0. And then the fourth term for this is finding a 0. Okay, so all 4 of these things are equivalent. So whenever you're asked to solve any type of equation, you're really finding the root of that equation, which is really the 0 of that equation, which graphically is the x-intercept. Okay, so using the factoring method, recall the zero product property. If you're multiplying 2 terms and those terms equal 0, then one or the other term have to equal 0. That makes sense because 0 times anything is 0. So when we factor, first things first, the equation is always set equal to 0. So when we look at part A, the factoring technique, there's a greatest common factor of x. So I divide that out of each term, and I'm left with x minus 3 equals 0. Once you factor the equation, then using the zero product property, I set each factor equal to 0. So I'm going to have too many equations. So my 2 solutions, x equals 3 or x is equal to 0. Okay, part B, my equation's already set equal to 0. So I'm going to set up, this is a trinomial, so it's going to multiply to 2 binomials. All right, x and x. The factors of -5 that add to -4 would be -5 times +1. As a quick check, -5 plus 1 is -4. -5 times +1 is -5. Now, for some of you, you may not need this intermediate step here. And hopefully, as we do more and more of these, no one will need it. So we get x is equal to +5 and x is equal to -1. So those would be our 2 solutions. All right, part C. Notice that the equation is not equal to 0. That's where we have to start. I'm going to subtract 6 from both sides. Only when my equation is equal to 0 can I then set the factors equal to 0 and solve. Okay, now notice your lead coefficient is not 1. So to factor this, you'll need a little bit of guessing and checking. So I'm going to leave that for you to do. Part D, we're a little bit rearranged here, but I would say as a rule of thumb, you always want to keep your squared term positive. So in order to get the equation equal to 0, I'm going to move towards the squared term. And I'm going to rearrange so it's in the form ax squared plus bx, and I had to subtract 12 from both sides. Okay, you can finish that problem. And then lastly, part E, again, when I look at my squared term, that's positive, so I'm going to move these two terms to the left. X squared, I have to subtract 8x from both sides, and then I have to add 16. Now the equation's set equal to 0. So please complete C, D, and E. Factor those for me. Okay, our next method is completing the square, which I think is a very useful method, but generally students are not used to it, so you don't use it as much. So when you complete the square, you make one side of the equation a perfect square trinomial. What's a perfect square trinomial? So trinomial, it's an expression that has 3 terms, and it fits this form. A squared and b squared are perfect squares. Notice I have a and b here. And then my middle term is just twice their product. Okay? A perfect square trinomial will also factor a minus b squared, a minus b quantity squared, square the first term, so square the first term, double the product of the two terms. So a times negative b is negative ab, and then I have to square that, and then I square the last term. So the last term is always positive because a negative number squared is always positive. Notice these only change, the only difference in those perfect square trinomials when we expand them is that second sign. And that second sign will always correspond to whatever the sign of the original is. Okay, so how do we complete the square? We take half of b is our coefficient to the x term, and then square it. Okay, so you'll have directions that say what value would you need in order to complete the square here. So here's b. I take half of b, and then I square it. 8 divided by 2 is 4. 4 squared is 16. Take half of b and square it. And this is why I notice every one of these expressions ends with a plus sign. Negative 5 squared is positive 25. Take half of b, fraction here, and square it. 7 halves squared would give me 49 fourths. And yes, you're expected to be able to do that. Half of b, 2a divided by 2, quantity squared. So I would complete the square with a squared. We will talk about in class what the factored form looks like. Okay, but every one of these has to then factor into some binomial squared. Okay, let's look at where it comes from real quickly. So if I go backwards, now I'm starting on the right-hand side of the equation. I have this trinomial. It fits the form. First term, I would take the square root of that. Last term, I would take the square root of that. And the sign comes from whatever this sign is in the expanded form. Now notice here, how do I know that it's a and b? How do I know that it works? If you think about taking the square root of b over 2 squared, what does that evaluate to? That evaluates to exactly that, to b over 2. So that's how I know that that's going to be my last term in the factored form. Okay, so what do these factor to? Square root of a squared, so square root of x squared is x. Square root of 16 is 4, and then I take the sign of my middle term. So that's what it would factor to. Next one, square root of the first term, square root of the second term, and I take the sign from the middle term. So all of these expanded forms are perfect square trinomials. So perfect square trinomials will always factor into either a plus b quantity squared or a minus b quantity squared. Okay, 3 would be x plus If I take the square root of this, notice what these square roots are. It's really just a square root of 7 over 2 squared. So that's exactly what b is equal to. And then lastly, square root of x squared is x, square root of a squared is a, and then I take the sign, the first sign that I see. Completing the square is a very, very useful method. It's very easy, it eliminates a lot of work, but we'll see as we do examples that the problem has to set itself up sort of nicely in order for it to be that easy to use. Okay, then lastly, the quadratic formula. This is the one that I feel students default to because you're most familiar with it, but it's certainly the most labor intensive. Same deal, equation has to be set equal to 0. A is the coefficient to the x squared term, that's my lead coefficient. B, coefficient to the x term, and then C is my constant. So once you write this down several times, I feel like you're comfortable with that. So in part A is equal to 1. Okay, it's the number, it's a coefficient. B is -3. C is -5. In B, A is equal to 5. B is equal to -4. And C is equal to +1. All right, so I'm going to have you complete these A and B. Use a quadratic formula to solve those. You're going to do those for homework in addition to the factoring ones. And then the last thing that I want to end with, okay, what's the business with this discriminant? So where does this come from? B squared minus 4ac all over 2a. So the discriminant is the expression underneath the squared, or the square root, excuse me. So the discriminant is what's underneath the square root, okay? Notice the discriminant doesn't use the square root at all. It's just that expression b squared minus 4ac. Why is it important? The discriminant is able to tell us, oh my goodness. The discriminant tells us the number of roots of a quadratic equation only. So here we are again. What does the roots tell us? The solutions, the x-intercepts, or the zeros of the equation. And it makes sense. If the number underneath the square root is a positive number, you have two real roots. That means you're going to get x equal one answer or x equal to another answer, or a second value. If what's underneath the square root is negative, we can't take the square root of a negative number. The only way we can take the square root of a negative number is by using imaginary numbers, is by using I. So if what's underneath the radical is negative, two imaginary roots exist. So they can be complex roots, and if we saw another one, it would be c plus di. Okay, but your answer is going to have to involve I. And then lastly, if the discriminant is equal to 0, think about if this number was equal to 0. The square root of 0 is just 0, so look at what's left. Your x value, you're left with negative b over 2a. So you have one real root. It just represents a double root. And as we start to graph, these things will make more sense. This is a special expression. Does anyone remember what this finds for you, that negative b over 2a? Okay, I'll see you in class.